I guess.
All right, so on Wednesday, we were learning, you guys started to learn how to solve equations using the box method. So we're going to practice today off the beginning of class here, just making some boxes for different scenarios. Go ahead. So what I'm going to do is I'm going to write an equation over here, and you're just going to make the boxes for it. So, for example, x plus 6 equals 10. Make the boxes. It doesn't. Nope. Will you help kind of explain to Chloe, because she wasn't here on Wednesday? No. Yours should look something like this. What are you asking there, Jasmine? I don't know what you're asking.
The numbers have to be like on the box.
Like in the box on the grid.
Yes. Because this box is X units long. We don't know how long it is. This box is 6 long. And this one is 10 long. So that is the equation that represents how long these things are. Okay? Everybody okay with this? Now, to make you think just a little bit about this, I'm going to challenge this a little bit because you're going to need this today. And that deals with subtraction. So this next one I'm going to put up here is going to be a little bit tricky. By the way, this one was x plus 6 equals 10. So this next one, I want you to draw the boxes for x minus 6 is equal to 10. I haven't taught this yet. I'm intentionally leaving this for you guys to try to be a little bit creative. So some of you may have to erase or scribble this out. I'm just telling you it's okay. I want you to think a little bit here and try something. And it's okay if you get it wrong and fix it. That is a way to do it, but that's not the best way to do it. So, not quite, but you're close-ish. You're close-ish. Now, what this demonstrates for me, and this is where I've spent a lot of time looking and reading and trying to figure some things out with this. One of the things that this shows me is that a lot of you know how to do the math procedures, but you don't have a conceptual understanding of it. Like, have you tried any of these? Have you done these? Have you tried it? Here's what I mean. is this box? Let's do it this way. How long is this box? We don't know. So what can we say for the length of this box? It's X. This box as a whole thing, that's a bad X because it wrinkled on me, but this whole box is X inches long, or whatever unit we're labeling it, right? So, what mathematical operation am I doing now? How much did I subtract? Some. I have subtracted some. Tori, tell them how long this is. This is 4. Okay? So, right here I have how long? I have X. I don't know how long it is, right? I didn't tell you you can't see any boxes. So this box is X units long. Tori told you that this amount right here, and you guys, struggling, is 4 units long. So how can I represent this box as an algebraic equation? X minus 4. Are we okay with that? So, when we get ready to try to do X minus 6, where did my Sharpie go? My whole length all the way down is how long? EJ? X. What did I do with that whole unit, X units long? I took away, in this one, how many did I take away? I took away 6. So in this one, I'm taking 6 away from it. Does everybody see how we're doing that? I love that idea. Again, I was researching it while my other stats kids were taking their final. I was watching a couple of videos on how to demonstrate this. I like that a whole lot better to show. The subtraction means I'm starting with this number. I'm starting with X, and I'm taking away from it 6. So, when I take this 6 away from it, what's left? What's that going to be equal to? JP? 10. So, this box right down here is how long? This box down here is 10. Because when I started with my whole thing X, and I cut 6 of it off, what was I left with? I was left with 10. So, what do I need to do to figure out how long X is? We need to fill this box in, don't we? How do I fill that box in? I need to add a number in there, don't I? Because I'm putting a new box in there. I'm filling it in, aren't I? So in order to fill that in, I'm going to add 6. So, how long will my whole box be? So my X is actually equal to 16. Now, think about that over here. Does that make sense over here? Yeah. If X is 16, what is 16 minus 6 equal to? It makes sense. Algebraically, what did we do? And most of you guys know how to do this algebraically. What do we do to this equation to try to solve it for X? We're going to add 6 to both sides of the equation, which what did we say we needed to do to fill this box in? We had to add 6. So when I add 6 to both sides, this is now back to a whole complete bar of X. We're not taking anything off of it. We're going back to the whole length of the whole thing. And on this side, we now have that new bar that is 16 units long. So X is equal to 16. Okay, a couple more here. Try this one. x is not equal to. We just say that there are two of them. So what we're going to have here is simply 2. We're going to have x. There are 2 x's. We're going to have those x together. So we're going to have 5. And we're going to have all 3 of those things together.
Imagine that this line is separating your top and bottom bar over
You're on the right track.
so
Keep looking. I appreciate you being able to do
this
this.
whole bar be on the right side of your hand. So
All right.
the bottom bar should just be on here. And then you'll have to, this is right, x. So just do that plus 5.
So we have 2 x's, and we have a 5, and then we have a 20. Start with the easy one. Where's the JP?
Oh, wait, what did you say?
I was going to say, where does the 20 go?
On the bottom.
On the bottom. I always like to start with things and get a little bit of steam rolling and start with the easy things. What's the next easiest thing to work with? JP? The 5. Where's it going to go?
On the right.
Goes on the far right. Does it matter where I draw this line? This is where a lot of kids were getting really hung up. Does it matter where I draw this line at? It doesn't. I can put it anywhere I want. I'm just going to put it right here in the middle, and I'm going to tell you that this box right here is 5. So, how much of this that's left are we needing to work with? Tyler? 2 x's. So what do we need to do with this area right here? Split it equally where both parts of them are an x and an x. Now, if we look across the top of this bar, how long is this bar?
20.
No, you don't know that. We have 1x plus 1x plus 5. This isn't 7. Where did the 7 come from? But that's not a 2. Is it? So, this brings up a point that I've had a lot of kids get stuck with, and why we talk about like terms. Is this x and this x like terms with this 5? So we cannot put them together. That's what a lot of kids try to do, is put those things together and say that it's 7. We don't know how long this is. We can figure it out, and that's what we're going to do, but we don't know what it is, so we can't add those things together. That's why we have to leave them separated over here as 2x's plus 5, because those aren't the same type of numbers. Are we okay with that? Now, how long is that total box equal to? Yes, we do know that it is 20. So what did we learn in class on Wednesday? What do we do to solve this? JP? We're going to get rid of this 5 from both sides, first of all. Because the 5 on top is the same as this 5 on bottom, isn't it? This box that I just drew down here on the bottom, we'll make it nice and solid. How long is this box right here that I just drew? It's 5. So I'm taking 5 away from the top. I'm taking 5 away from the bottom. Algebraically, what does that look like? Tori, what does that look like over here algebraically? Minus 5, minus 5. So what does that leave me with? Visually, on the left side with the boxes, what does that leave me with if I took those 5s off of there? 2 x's, and it's no longer 20, is it? It's no longer 20 because we took some of it off, didn't we? What's left down here on the bottom? There's 15 that's left down here on the bottom. What do we get over here when we do that? We have 2x on this side, and we have 15 on this side. Now, we need to finish, and what I want is I want to get it to where I just have 1x. So we're going to split that 15 right down the middle so that I can get just 1x. Noah? So what is x? Right? Very good. Are we okay with this idea of setting up equations with our bars. Okay? Now, I need to get more paper because I already know. Here it is. Now this will work. We're going to take and add a little twist to this. You're just like, I was just getting this. Right? That's what Mrs. Bowling and I were just talking about that earlier today, where that's kind of what math does, unfortunately, is I was just kind of getting the hang of this, and then we're going to add the next thing to it, right? That's always going to happen with math. There's always more. So, beware. I'm just telling you right off the bat. Beware. You're going to have to think a little bit. Notice I'm not giving you the rest of this. I'm only giving you one side of it right now. So all I want you to think about is how do we do just the top box with this? Keep in mind, what's our idea with subtraction? What are we starting with? What's the whole thing? What am I starting with? What am I starting with in this as the whole thing? What did you say, Jasmine? 2 what? I'm starting with 2 x's. So this entire box needs to be what? Needs to be 2x. Because I'm starting with the big thing, and then what am I doing with the long part of it? I'm taking away from it. So I'm cutting off a certain amount. How much am I going to end up cutting off of this? Sorry, that's up there above. I'm cutting off of this 5. Do any of you know, I can use words. Do any of you know what x is based off of this? We don't know what it is because we don't have any other equation part of this, right? So what if I tell you that this is equal to 17? Where does that 17 need to go in my box? Is it the whole length of this? Is it just the 1x? Is it the whole length? It's not the whole length. Remember when I was doing this? What's the whole length? The whole length is x. And if I take 4 off of it, what's left? Whatever this is, right? Whatever this is equal to. So in this situation, this is really 2 x's. I should probably draw 2 x's on here, but you guys, I hope you can visualize that, right? How much am I taking off of this 2 x's? No, not on this. How much on this problem? How much am I taking off of these 2 x's? I'm taking 5 off of it. And what does the equation tell me that this now should be equal to? This should now be equal to 17. Where's that going to be up here on this graph? Or on these boxes? Good, Tyler. Right where I cut it. This is now 17. I started with 2 x's, and I took 5 off of it. When I take those 5 off of it, I'm left with 17. JP? So what would we do mathematically now to solve this equation? You're absolutely right, JP. You're starting to have the connection between the visual with, can't we just do this? Isn't that what we do? What do we need to do to finish this out and find this whole length? We need to add that 5 back in so that we're no longer losing that. What does that look like over here on this equation? plus 5 on each side. So what's my new boxes going to look like? What's on top? We have 2 x's on top, don't we? And what's on bottom? Over here, those went away, didn't they? And so we're left with 2x equals 22. Now we want to get just 1x. Very good, Jasmine. We want to get just 1x. So how much is just one of those x's going to be? When you get it, it's fun to answer, isn't it, JP? I want everybody to be able to kind of have an answer too. Because when you get it and you know how to do it, and you want to answer all the time, you kind of take that opportunity for other people to think away. Right? So I want everybody to have kind of a chance. All right. So, starting this. This is what we're working on today. And before you guys get too far along in your thought process, my answer is yes. My answer is yes. You have to do both. You have to do both. The equations and the boxes.
Yay!
What number was it again that we need to fix? Number 6 has a mistake. We're going to get to this on Tuesday next week. Everybody turn to number 6. There was one snuck in here that we're not ready for yet. What do you notice about number 6 that we're not quite ready for yet?
You got another thing on the other side.
We got another F on the other side. That's what we would do, but for now, because of the way this one is set up, we're just going to cross that F out. 3F minus 7 is equal to 11.
So is this actual algebra now? Are we doing actual algebra?
This is what we were doing first semester, too. To answer your question, Star, yes, this is algebraic solving.
This looks like real algebra, not like the actual equation stuff.
Well, it's connecting the algebra process to the algebra concept, yes. Okay? All right. You should be able to finish this before you leave. However, I'm going to tell you, number 10 is tricky. And we're going to spend a few minutes here in a little while working through number 10 together. But I want you guys to get there first. You need to get lots of practice with this. And then we're going to look at number 10 together.
There's a question. You have blank space and you can create the
Boxes.
boxes.
Yes, you have to do both the boxes and the equation. All right, take a look at number 10 here. The whole box is 20. How much of that box are we taking away?
12.
No. We're taking 2J away from that box. We'll get there in just a second. We're taking 2J away from that box. There's 2 ideas that we can do right here. I'm going to do this both ways for you. This is where it gets a little bit tricky. What's left? How much is left? 8. So how long is this part right here? It's a negative 12, isn't it? The whole thing is 20. And we took away this 2J and we were left with 8. We know that this has to be a negative 12 as well. So over here we have negative 2J is equal to negative 12. How do we solve this now? What would we do, JP? Divide by -2, divide by -2, and we get j equals 6. That's the algebra that you guys have learned how to do. So let's talk about it from the original beginning part of the equation. 20 minus 2j is equal to 8. What's the first thing that we need to do to solve this equation? What do we do with the 20?
You
Subtract it. And what's that leave me with? -2j is equal to that -12. Why are we dealing with the negatives? JP? Go ahead, ask your question. That's okay. I'll come back to my question in just a second.
It's kind of the same too, but I did this whole like different.
And you got the same answer?
I did.
Hold on, don't say what you did yet. But you did a different way, but did you still get 6?
Yeah.
Okay, I'm going to come back to your way because that's the other way I want you to see this. I heard your guys' discussion. Ms. Boleen said you guys were having a really animated discussion about it. This is not the only way to do this. So I'm going to come back to it, JP, and I'm going to let you explain in just a second. Tyler, I think you started to raise your hand. Why are we dealing with the negatives on both of these? Was that the question that we're going to answer? Why, though? From our bar diagram, why are we working with only the negative parts of this? If we look at our paper that we're working with, right? What are we doing with this part of the paper? We started with 20. Everybody agree that we started with 20? And what are we doing with this part of the paper? We're taking it away. What mathematical operation does it mean to do when we are taking something away? Subtraction. That's why we had to represent it as a -12. That's why we represented it with a -2j. We are taking it away. We're leaving the 8. We're not even going to mess with the 8. We're only dealing with the negative part of the equation. Now, JP, you said you did this differently. I would love to hear. Do you want to even come up here and do it? Or do you just want to say it out loud? Just say it out loud. That's fair. All right, let me reset this so that it all looks the same because we have to fix all this. So we have a -2j right here. All right, JP, what did you do?
Okay, so under the half of the like the shaded 20, I put plus 2j.
So you filled this bar back in. Good.
And then I put 20 equals 8 plus 2j.
Stop. Perfect, but I want everybody to catch up. This is what we had been doing, wasn't it? Where we take the negative part and we fill it in to make 2 equal bars. Is that okay? That's what we just did with all the ones before, wasn't it? So you just kind of did the same thing, but we did it with a variable instead of with a number. Keep going, JP. So you subtracted the 8 from both sides. So you got rid of all of this. You split it in half. And you got 6 equals j.
So we did it opposite?
He worked with the opposite side of it. What does it mean if we worked with the opposite side of it?
It will be the same.
He changed the signs of everything. Did you know you did that? You didn't, but is it okay that he did that? Did he still get to the same result? He got to the same result. There are multiple ways that you can manipulate this. Now, interestingly enough, is it okay if I share, Mrs. Boleen, what we were talking about earlier? So, Mrs. Boleen came up to me earlier and said, so, earlier this year, you were teaching them that they had to move everything to one side of the equation, the variable on the other side of the equation, and then we talk about doing it this way. Is that okay? And my answer was absolutely it is. Because the fundamental theorem of algebra, not that you need to know this, but the fundamental theorem of algebra says you can do anything you want to an equation as long as you do exactly the same thing to both sides of the equation. Did JP do exactly the same thing to both sides of the equation when he put plus 2j and plus 2j. He filled in this negative part and made it a positive. He filled in this void part and made it a positive. Is it still equal? You can do whatever you want as long as you do the same thing to both sides of the equation. Let me show you a really simple illustration of this in a silly, silly version. X equals 2. Kind of just a simple equation, right? We know that x is 2. X plus 4 is equal to 6. Is that still the exact same equation?
Yes, probably.
Yeah.
What did I do to go from this step to this step? I added 4 to both sides of the equation, didn't I? I wouldn't ever dream of doing this for what we're trying to do because we're trying to get x by itself, and so I'm adding more things to this. So I'm not actually helping myself, but am I doing the exact same thing to both sides of the equation? So then my next thing, could I also say this? I would never dream of doing this, but could I do this? Because as long as I do the same thing to both sides of the equation, there's still equal parts on both sides of the equation. Could I then do this? Why? It's a great question. I would never dream of doing this, but have I done anything illegal mathematically? I did the same thing to both sides of the equation. What about this? Is that true? It's illegal. Why? I didn't do the same thing on both sides of the equation, did I? That's no longer true. So, does it matter whether you decide to work with the negative side of it and do the negatives, or if you do like JP said, well, we're going to turn it all positive and work with the positives? Okay, turn your paper over. Turn your paper over. I want you to add 2 problems, but then we're going to go to the boards, and I'm going to have you do these 2 problems. Let's just do one. Let's just do one. Okay? One problem, and you're going to go to the boards and do it at the board. I'll let you pick. I shouldn't say that, but I'll let you pick your groups. No more than 3 in a group. No more than 3 in a group. Pick your groups, groups of 3. Here's your equation. There's your equation. Go to the boards, do this problem, and then when you're done with it, you can turn your worksheet in. I want it both algebraically and as a bar. Yeah. No, just on the board. Only reason I made you write on your paper so that you could see it. I want you doing it both ways. Algebraically and with a bar.
That's marker. What do you think? This marker is not a marker. This is a brick.
I'm thinking.